Okay, Assalamualaikum. So today we continue our lesson on chapter 2 and the subtopic is balance fault. Okay, balance faults. So by the end of this subtopic, students should be able to determine fault current, bus voltages and line currents when balance faults occur in the power system network. Okay, so this is our outline for chapter 2. So we already finished single line diagram, reactance and impedance diagram, per unit system, component representations, steady state approach using per units approach. So today we will focus on balance faults and short circuit capacity. Okay. So faults of power system can be divided into two main categories, which is balance three-phase fault. This A, let's say this A. Okay, type A is balanced three-phase faults. Okay, let's say we have three line, red, yellow, blue, red, yellow, blue. Okay, three-phase fault is faults occurs on these three-phase line, balanced faults. Either faults occur on red, yellow, blue, red, yellow, blue, or red, yellow, blue to ground, or grounded faults. Okay, to ground. This is a balanced fault. Another type of fault is unbalanced type of faults. Okay, let's say this B, unbalanced type of faults. For unbalanced type of fault, we can divide this type of fault into three categories. Okay, three subcategories, which is single line to ground faults. Let's say we have red, yellow, blue, single line to ground faults. Either one line is faulted to the ground. Let's say this line faulted to ground. This is single line to ground faults. Okay, this one double line faults or line to line faults. Okay, let's say we have three phase, red, yellow, blue. Either these two lines faults, okay, red, yellow, blue, or yellow to blue faults. Either one. This is line to line faults. The other type of faults is double line to ground faults. Let's say we have this red, yellow, blue. So these two phases faulted together and then faulted to ground. Okay. Okay, this is a double line to ground faults. So we have three subcategories for unbalanced type of faults, which is single line to ground faults. This one, line to line faults. So either red to yellow or yellow to blue. Okay. And another one is double line to ground faults, something like this. Okay. So in this subtopic, we only cover balanced type of fault, which is the faults type number 1, A, three-phase balance fault. Okay. For unbalanced type of faults, this topic will be covered in the power system analysis subject. This one is quite simple. Type 1, type B is quite complicated. Okay, so we just focus on this type of faults. Okay, life of faults. Life of faults depending on the periods of faults. So we can divide the life of fault into three categories. One is subtransient. Subtransient, usually when fault occurs, current, let's say this current, magnitude of current, this time, duration. When fault occurs, current will increases significantly. Okay, something like this, and then start to stabilize, and then steady state. And this few cycle, we call it as subtransient period. Subtransient, transient. Okay, only few cycles of faults, transient duration, maybe 10 of cycles, and after that we call it as a steady state period. Okay, so this is the life of faults. So during a few cycles, the fault current is very high. It's jump very high and then it start to dropping for a few cycles, and then after that the fault current reduces during the transient period, and then when the steady state, the fault current will become steady in the magnitude. Okay, so this is the life of faults. Okay. So if we look at the balanced faults, usually the information used from the fault current can be used to select and set a phase relay. Okay, what is the function of phase relay? This phase relay is used to tell the circuit breaker either this magnitudes of current is a fault current, or this is the ordinary type of current or load current. So to differentiate between fault current and ordinary current, relay is being used. Okay, so another one, line to line faults, okay, is used for the ground relay setting. Okay, so in our case we use 3-phase balance fault to set up or phase relay setting. Line to line or line to ground fault we use for ground relay setting, and other type of fault we use for other type of setting. Okay, fault studies are also used to obtain the rating of protective switchgear or circuit breaker. Okay, so we want to select the right size of circuit breaker or switchgear, we have to know what is the maximum or the fault currents magnitudes during the faults. Okay, so the magnitude of fault current depends on the internal impedance of the generator. Okay, so in this case, usually for the generator we have Xg. Okay, this is Xg for steady state. So we have Xg subtransients, Xg double prime, we have Xg transient, and we have Xg steady state. Before this, we only use this Xg, internal impedance for the generator, for the steady state, because we are doing the steady state analysis previously. But for the fault study, sometimes we will use Xg subtransients, this one Xg double prime, or Xg prime, depending on what type of analysis we want to do. Okay, so this is a cause of faults. Okay, sometimes faults occurs because of lightning, heavy winds, trees falling, and so on. Okay, balanced 3-phase faults is a simultaneously short circuit across 3 phases. Okay, generally, subtransient reactance is used to determine the interrupting capacity of the circuit breakers. Okay, so we use subtransient reactance, okay, to determine interrupting capacity of the circuit breakers. If fault studies require for relay setting, transient reactance is used. This is what I said just now. We have, this is Xg double prime, subtransient reactance is used. For the relay setting, we use Xg prime. Okay, this new, this is maybe new for you, because previously we only use Xg for generator, steady state reactance. Okay, steady state reactance. So if fault's impedance is equal to 0, okay, fault impedance equal to 0, let's say this X fault equal to 0, so we call it as a bolted fault, or sometimes we call it as a solid fault. That means X fault is equal to 0. There is no impedance, okay, when the faults occur.